Hello, so now what we want to do is we want to test the little Hall effect board that we've made. And I'm going to show you a couple different ways to do it. We're going to do one where it's on a breadboard like this. And I'm going to do another where it's on a motherboard like this. And show you how to hook it up and some simple demonstration code that we can use to see if it's going to work. And what we need, of course, is a teensy in one form or another. We need the board you made, and you're going to need some wires. Something that is both male and female if we're going to do it with the breadboard. Okay? So we need to have the male ends to be able to stick into the breadboard and the female ends to be able to hook over the pins on the Hall effect sensor. The first thing we should probably do is orient ourselves where we're going to, what pins we're actually going to use. And if we look at the provided card, you can see that the teensy itself is a VN port here. This is where we're going to take our power and off, and we're going to use it to power the Hall effect. Just across from it, across from the USB, we've got a ground pin. Okay, so we can plug into this to give us ground. And last but not least, these are the analog pins down here. And the example code that we're going to use, which is already built into Arduino, uses A0 or pin 14. So we'll tie into that second pin from the back. All right. So that being said, we want to choose logical color patterns for our device here. By the normal color patterns, what you'd want to do is you'd want to use, for example, the red is going to be our power pin. You would use a dark color, preferably a brown or something like that, for ground. Okay, like I said, I'm plugging them into these first two pins next to the USB. And last, we're going to need the yellow or a light color for signal. And it goes into the second pin from the back of the chip. Now this gets plugged into the Hall effect sensor. Okay, I'm going to go ahead and plug in the signal first. And it goes signal, power, ground. You'll see it's labeled here as an S, a positive, and a negative. I'm going to hook up the ground next. And last, I'm going to power this guy up. Like so. And there we go. Okay, so I've got it hooked up. Okay, I got signal, power, ground. And now it's time to pull up an example piece of code so we can kind of test out our Hall effect sensor. So let me do that. Let's go ahead and pull up some Arduino. And the code I'm going to use is going to be under examples, then basics, then analog read serial. I'm going to go ahead and close this piece of code right here. Okay. And then what I want to do is I want to change one thing. It flies by. It takes a sampling every millisecond. Newer computers, that's great. I'm using an older computer here. It tends to clog up my serial port, sending data faster than I can receive it. I'm going to slow that down quite a bit, and I would recommend doing that just to be safe. Whoops, put in O's instead of zeros. There we go. So I'm going to slow that down to 100 millisecond or 10 times a second. We're going to go ahead and display the data. Next thing I'm going to do is check to make sure that I have the right teensy, and I do, and that I'm connected to the right port, okay, which I am. And now I'm going to go ahead and load this up. And I'll pause it while it's loading because there's no particular reason why you need to wait for that. Okay, so it's done loading, and I just want to show you something else that's really cool. I think is useful for playing around with sensors. Of course, I can open up the serial monitor, and you can see that I'm getting a bunch of numbers out, and we can talk about that later, but I have that actually putting out the numbers. But for something like this, I think it's actually cooler and more useful to use something called the serial plotter. So if I go to Tools, I can find the serial plotter here, and you can see that I get this nice graphical display. All right, and here I have a magnet. Let me get this out of your way so you can see. Here I have a magnet, and I'm going to bring this magnet closer and closer to the Hall effect sensor, and you can see that I get a really nice proportional signal depending on the distance. Not only that, but if I flip the magnet over so we get the opposite polarity, you can see that now I rise well above the baseline. Okay, so it is also sensitive to the north and south poles of the magnet, as well as just the proximity to it Oops, of course it sticks right to it. There we go. All right, so it works great. So let me show you here in a second. I'm going to set up this on a regular PRT motherboard, and I'll be right back. Okay, so now I've got it setting on a PRT motherboard, which is already mounted to a 1-bot, and I'm going to show you how to hook this up and test it out. In this case, I'm going to use this much nicer 3-filament wire. Okay, so everything's kind of hooked and clumped together. And I'm going to go ahead and plug this 3-filament wire. Again, what I want to do is I want to use the lightest color, the yellow in this case, to be connected to the signal, and which is going to go then like this. All right, and then I'm going to hook up the same thing here. Again, keep in mind that we want to go to pin 14, which is A0, which is the second one from the back. And once again, I'm going to have the signal wire closest to the chip. So the yellow is going to line to the yellow, the red to the red, and the black to the black. Signal, power, ground. And I'm going to plug this guy in like so. All right. It is super important you do not allow this board to touch the metal chassis. Do not mount it directly to the chassis. If you're going to mount it, please use a nylon spacer or some other way of insulating. It will short out. Okay, you would just ground out the power, ground, and signal right up against each other against the metal chassis. Don't do that. So now let's go ahead and pull up the code. I switched to a different TNC, so it means I have to switch to a different port. Everything else remains the same. Let me go ahead and upload it. I'm going to pause it while it uploads. Okay, it's uploaded. Let me go ahead and open up the serial plotter, and let me get this in the forefront. I'll move this over just a little bit so we can see things. And let me now take the magnet and bring it closer, and of course we get that really wonderful relationship between the distance and the signal, and we get this polarity effect where I can bring it well above baseline. Okay, so hopefully that was informative. I do want to show you this. Let's see what happens when I try to, this would be gratuitous educational content. If I try to load it with this window open, it will not work. Okay, it says it worked, but it never actually did upload. It's still running the same thing. Here we go. Now I've got the error. All right, this has to be closed for you to upload. All right, so it cannot be using the serial port in that case. For plotting, that has to be closed. Then you can reopen the plotter and everything will work great. Okay, so hopefully that was useful, and I'll see you again soon.